Hello, this is a Zeltex ZX101C portable near-infrared octane amp, and I'm going to be giving a brief demonstration of the instrument's functionality and some basic maintenance for the instrument. The first thing we need to do is to get current to the instrument, which can be done either by means of the AA alkaline batteries seen here on the left or by means of an AC adapter, as you can see here on the right. In order to connect it, rotate the instrument on its side and we can see the on and off switch, the PC connection port, and the AC power line. It only fits in one spot. Rotate it over. Turn the instrument on. When you hear the chirp, you know that the instrument's functioning. It flashes up the version of the EEPROM and begins counting back from 15 as it does a self-diagnostic. This can be shortcutted by pressing the clear button, and it now reads 0 adjust, which means the instrument is now ready to accept the sample. If you do not have AC current available, it's going to be removed, and the instrument can have the batteries loaded in. They are loaded in an alternating fashion, back to front, just as you would in any other electronic device. Replace the cover. Turn it back over. And there we hear the chirp again. And it begins counting backwards from 15. Now, we're now ready to run a sample as soon as it finishes with the diagnostic. We have a light shield here on the right, and we have a sample of gasoline on the left. So, when we get the 0 adjust, with the light shield in place, anytime you take any measurements whatsoever, the light shield must be in place. And it says 0 adjust, and now we press 0. The instrument will display a reading, and we'll wait a few moments. The instrument is now taking a measure of the inside of the chamber in order to determine the standard level. The instrument chirps and now reads put in sample. Now when we do this, you'll notice that there is a stripe on the sample holder, which corresponds to the stripe here and to the stripe here. Line it up with either one, it doesn't matter which. Place the sample in and press measure. Now, while the sample is reading, what that does is it allows you to line the sample up so that the windows in the side line up with the sensor. And rotate the cup 180 degrees so that the line matches the other line. Place the light shield back in place. Press measure. We'll now take another measurement of the empty chamber. Press 0 adjust. The printer now starts printing, and we see the date and time group across the top. The printer will also give you the automatically give you the sample number, which will move up in increments of 1 unless you designate a manual sample numbering system. It also shows you that we have a gasoline calibration. I think we can come in. There we go. You see there sample 164. We are using a gasoline calibration. That's why it says gasoline right here. And it displays RON and MON separately. And R plus M over 2 is automatically averaged in the instrument. For the next section, I'd like to show a couple of the maintenance elements that you may have to do. The two primary ones are to clean out the inside of the sample chamber and to replace the printer paper. And the maintenance on the chamber is really very simple. there's not a whole lot to look at. You just can't really go wrong with it. If you look at it, you want to make sure that there's no buildup, that there's no paper, that there's nothing on the inside. It should be nice and clean, and that there is nothing on the two sensor areas, which are the, you can see it right here. This is the actual photo sensor right here on the far end, and on the closer end we have the light diffuser, which is attached to the light source. The maintenance for these is if you notice there's anything built up on them, that there's something you can't just kind of blow out with some compressed air, is to take either a Kim wipe or something like a Q-tip and very gently, just using some warm water, very lightly wipe it off. Not a lot of pressure, just kind of clean it off. As we said, just use some warm water, don't use any harsh abrasives, and don't use any solvents. The other project you may find yourself working on is if you run out of printer paper. And we use printer paper just as anybody else, and most people find it helpful to tear a bit of a point into it. There's a slot in the back, just like there would be on an office printer. And just kind of put it in here, and get it down there. Press the paper feed, and after a few tries it'll catch. And as the tip works its way up to the paper cutter, you can take a hold of it, tear it off. The paper then goes in the area that was before, and the lid is slid into place. And that's the changing of paper. Should you notice that your instrument is reading uniformly low or uniformly high, you will need to make an offset adjustment. What you would do to do this is to confirm how far the instrument has drifted by comparing the RON and the MON separately to the knock engine RON and the knock engine MON. Included with your instrument is software that allows you to do this, or you can send in the results to Zeltex and we'll happily calculate these adjustments for you. Please send them in via Excel spreadsheet if at all possible. Once the results have been calculated, it's now time to adjust the bias or slope, and the method for doing this is found on page 10 of your user's manual. It will say adjusting bias or slope, and the process goes very much like this. Step 1 is to turn the instrument on, which we have already done. After the countdown, we'll press clear and then select program. And then clear 882. After we press clear 882, the instrument will display enter product number. And I think I can get that for you. Here we go, enter product number. The product numbers are listed from 0 to 9. By convention, gasoline is 0, ethanol blended gasoline is 1, and diesel is 2. We are adjusting gasoline, so we press 0. And it will read gasoline. P0 is product 0, gasoline. Now we're going to choose the constituent. The constituents are 4, 5, and 6. 4 is RON, 5 is MON, 6 is the average of the two. And we will be averaging today the RON, so we'll press 4. I'll say product 0, C1, RON. From here we press 3, and again all of this is on page 10. I'll say bias. Now we will send you results. There will be two numbers. One will be a bias and one will be a slope. For the bias, for example, we want to put in a 1.00, and you can go back by pressing the clear button as I just did. And there's also a minus button, and this is how we toggle back and forth to positive and negative adjustments, such as the one we have here. Once the adjustment is in, let's press enter, and it will now ask you for the slope. The slope is another number that we'll provide you, and you can enter it in like this, 1.04. Then press enter. At this point, the printer will come into play, and what it's doing right now, I think I can zoom in on this for you as well, is printing out the old slope and bias, which are 0 and 1, which are the default values. It's showing the values that we just entered, which are 1.00 and 1.04, and it is also showing you the new values that are the resultants of entering those values in. Then it gives you a date and time group, shows you the constituent that was worked on, and that allows you to store the results of the changes that you made to be stored in your lab records.